So what we do know is that the difference in age. We know that the father's 50 and the son is 8 years old. So I'm going to just sit here and talk about the father right now, and I'm going to call him F. Okay, so the father, or this should be actually say the father's age. I know it's 50, but I'm going to still call it F. Okay, now the son is 8 years old. So if the father is F, okay, how much younger is the son? Well, he's F minus 42. He's 42 years younger. So let's come up with an equation, or this should say son's age. So how long until the father's exactly twice as old as his son? So when is the father's age twice as old as his son? Okay, father is twice as old as his son. So I'd solve F equals 2F minus 84. I would subtract 2F, and I get negative F equals negative 84. F is 84. So what does that mean? Well, that's the father's age. Okay, when is the father going to be twice as old? When he is 84 years old, and the son is 42. So how long until then? Well, if he's 50 right now, that means it's going to be in 34 years. It will take 34 years. Okay, so a little different, that one. You know, and I'm sure there's different ways you can go about solving this last one. Okay, but I think one of the just kind of straightforward or kind of easy ways is I just simply label the father, okay, or whoever we're talking about, whoever we're comparing to, the variable, and then I just use the age difference here. Okay, if he's 50 and he's 8, then it's obviously you take away 42 years. If he was 20 and he was 6, you would take away 14 years. Okay, and then I set up my equation and solved. Okay, and then at the very end, I made sense of my answer. The F is 84. Well, what does that mean? It doesn't mean it's 84 years. It means that's what the father's age is when it happens. It's 84, and obviously the son is 42, and that is twice as old. So I hope that makes sense. That's age problems.